Okay, so as you volleyball ladies might be choosing to tune in, we said we would try to put something together for being absent for today. So let me help you with this, and that is the author chooses to illustrate how energy is created way back in section 8.1. And we drew this diagram, okay? And you probably have this in somewhere in your notebook, and you wrote it down, okay? Without any further context, what could you tell me that is? That's called adenosine triphosphate, or ATP. So what happens, whether it's mammals, humans, plants, this is one way that organisms can create energy for themselves, because once or if this bond is broken, which it does, and if you have two phosphate molecules, if this is ATP, what would, oops, I went to draw a triangle. What would that be called? What molecule do we have here now? Yeah, so adenosine diphosphate, or ADP, and then all the way out here on the end, you have a monophosphate. Yes, go do that. Okay. Seriously? I would agree. All right. So what happens then is plants and animals, we get energy when this is broken. So what do we get from this? Well, like we said, energy is given off. Okay? So this just doesn't show up in molecules. It has to be made. Okay? So then what happens, what plants will do in what we call the light reactions, okay? That was section 8.2. So in this process, we know as photosynthesis. Okay? The biggest takeaway from that is something gets split apart. Do we happen to remember what that was? Okay? So, and I know we talked about this. And we're just trying to refresh your memory because it is Monday now, okay? So what we're talking about here, okay? I think I went too far back. I know it's in here. Here we go. Okay? So in this process, in photosynthesis, we said something gets split. What is it? Yeah, so all the water molecules get split. So this is where the sunlight comes in. Okay? Because you have this molecule of water, which we know, of course, is H2O. So when this gets broke apart, you have lots of these floating around, okay? So hydrogen atoms and also oxygen. But notice when we say that plants give off oxygen, it's not in that form with just one oxygen atom. And I think somebody had answered that correctly before. It's not just one oxygen atom, it's two, because oxygen is diatomic. Okay, so then these oxygen atoms get put together and then get released to the atmosphere. But the significance of this is that when that water molecule is split, notice if this has a positive charge, there must be some of these guys floating around. So what might the E be standing for? It's not a proton, it's an electron. So the reason that that's significant is because in this process, okay, What's being transported? Electrons. So when that molecule of water gets split, those electrons from those hydrogen atoms are pushing along this chain. Okay? So the electrons are pushing this hydrogen along because the charges will repel each other. Okay? So notice that this has a positive charge. These electrons are negatively charged, so it pushes this hydrogen along. And eventually what happens is that pushes the hydrogen out of the cell membrane, and then this molecule ATP synthetase. Okay? What that does, okay, is causes this to come back together again. That ATP synthetase causes ADP to turn back into ATP. So then what happens when the ATP molecule gets broken apart again? What do we receive? When this molecule gets broke apart, what do we receive from this? It's right here. You get energy from that. So this cycle just continues over and over again. This is how plants get energy for themselves. They will break down the ATP to ADP. This molecule gets split apart. You have free-floating hydrogen atoms that get pushed along because of these electrons in what we call the electron transport chain. Okay? And then it's those hydrogen atoms that cause ATP synthetase to change ADP to ATP. So this is where that ATP synthetase is. Okay? So that was what we call a brief overview of section 8.2, I think, maybe 8.1. So to help you on your papers, section 2, sorry. Okay? What would you guess has to be present for this to take place? When does it take place?
During the day.
You're right. Why? Because you need sunlight for photosynthesis to take place. But remember, plants need energy. It's always ongoing. So they have to be able to produce energy for themselves also at night. It's not going to take place because of photosynthesis. I mean, you can't get enough solar energy. Well, solar means sun. You can't get enough energy from moonlight alone. Okay? So there must be another way. Phase 1 would be the light reactions. That's why, or electron transport, whichever way you want to look at it. Phase 1. Okay? Phase 2 is the Kelvin cycle. So what happens is during that video that we had seen, okay, Rubisco is this molecule that grabs carbon dioxide molecules out of the air, okay? So it converts these molecules into organic molecules, mainly sugars. Well, not mainly. It is sugar that is doing that, okay? So it is these enzymes that can be used by the cell then, okay? So in essence, I think we had seen that, and just as a quick refresher, I'll get this up on the screen so we can all see it. Okay, so this is what we were talking about earlier. You have phase 1, the light reactions. Here we have phase 2, or the dark reactions, which is known as the Kelvin cycle. So what we see happening is out of the atmosphere, you can see this carbon dioxide then is being grabbed by Rubisco.
Of carbon dioxide.
So I'll back that up a little bit.
Cool enzyme because it makes life on Earth possible.
Rubisco may not look so special, but it is arguably the most important enzyme on the planet because of its critical role in photosynthesis. Rubisco's job is to grab a molecule of carbon dioxide and feed it into a molecular machine that's building carbon chains. That means any carbon atom that's part of any plant anywhere got there thanks to Rubisco, or one of its close variants. And because we eat plants, or animals that ate plants, that also includes just about every carbon atom in your body. All approximately 800 million billion of them. That's 26 zeros. Not bad, Rubisco. Not bad.
Yeah, so if it's ever come from a plant, it has.
Okay. So that is what is happening in the Calvin cycle. That enzyme Rubisco, as you can see, is grabbing carbon dioxide molecules. Okay. So on that back page, okay, what are two alternative pathways plants can take as opposed to the light reactions? Because the light reactions is photosynthesis, and that's what we were looking at here just briefly. Okay? So again, photosynthesis is the light reaction. Rubisco is involved in the Calvin cycle, where it's grabbing those carbon dioxide molecules and linking them together into a polysaccharide. Just means sugar, 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 monosaccharides making a polysaccharide. So that is one way or alternative pathway to create energy because it's making sugar. The other way, sorry? Calvin cycle. It's just that Rubisco is used. I keep saying Rubisco because that's what's doing the job in that process. Okay? So then the second alternative pathway is what we call the C4 pathway. Okay? Because as the question goes on to state, what do they do limit the loss of what substance and fix what substance? Okay? So what are we minimizing in the Calvin or in the C4 pathway? What does it say at the bottom? No, that's the light reactions. Yeah, because one of your vocab terms was, I think it says stoma, but it's supposed to say stroma. Those are little tiny openings in leaves. You probably can't see that because it's so bright. Okay? Or those little tiny openings in leaves. So what happens is at night, those stromas will open up. So then, once those open, what can flow into there freely, would you guess? Not if they're open. Carbon dioxide. Okay? Because this carbon dioxide will then get fixed into what compound? It says it's fixed into a 4-carbon compounds, but it's sugars. It's making sugars for itself. And then we will address section 8.3, which deals with that last question. Okay? Because there we're starting to talk about, again, as it says, why, when muscles run low on oxygen, what process halts, and how do we continually supply energy? That, I think, is going to be a longer topic of conversation than what we can get done today. So we just want to help you along with that paper. Review what's happening during the light reactions. Starts with the P. Photosynthesis. The main takeaway from photosynthesis is something gets broken apart. Excuse me. What gets broken apart? water. Okay? So then all the free-floating oxygen starts to pair up with one another and gets released to the atmosphere. Okay? What is the significance of what's left over with that water? So we talked about oxygen. What about hydrogen? It gets pushed along. Those hydrogen ions get pushed along by something. What might be pushing the hydrogen ions? Close. What might be pushing those hydrogen ions along? What are these? Electrons. That's why it's called the electron transport chain. Okay? Then, what is hydrogen's function in this? Has something to do with this. Because what is that ATP synthetase going to do? It's a red line. It's going to cause ADP to be fused with another phosphate to make ATP. So this cycle, it just continues and continues and continues. So when that phosphate gets broke off, energy is released. That's why we have that circled up there. Okay, so we'll have something for you to work on tomorrow, meaning a diagram and what cellular respiration is. Okay, and that is on and about page 230. Okay. No. You'll have your vocab quiz tomorrow. Okay. And then, it depends. Maybe there'll be time. Maybe there won't be. Okay. I have every bit of confidence that you'll have time left over. So then we can have you tie into, anybody's computer can tie into that and get the rest of the content needed. What do we have for a due date? It says 9/18, which is not going to happen. Okay? The vocab is due today, but we have so many people gone, so we will look at those on Thursday because I will not be here tomorrow. So you will have your vocabulary quiz, and we'll tie in the rest of section 8.3, or the rest of the chapter, I should say. Then we will worry about what happens on Friday once that gets here. We can discuss that on Thursday. Okay. Is Thursday an away game for volleyball?
Yeah.
And are volleyball players absent for that too? Okay. And you leave at 2 o'clock on Friday. Okay? So we'll just probably do something very similar to what we're doing here. Try to tie all of these concepts together, because if you're having problems with this stuff, it's not easy. So that's why we want to make sure we continually review it over and over again. And if you don't get it, you've got to say something. I mean, us staff members, we're not mind readers. Okay? So anything else you would like to add? Questions about due dates or something? No. I don't think so. We're just going to have one big review on Friday. And just like I said, we're going to put something together on the Science Channel for people who are gone. Okay? Now, so we'll try. There's certain things we just don't have control over, and that is when schedules change, we just do the best we can to get through this content. Okay? And I realize it's not the most fun, but we're trying to get through it. And if it's taking longer than it should, which maybe it is, you want to be mad at me. Okay? All right, we'll catch up to you next time.